Welcome back. We are discussing about the wastewater treatment. In this video, we'll be talking about some problems based on BOD calculations. BOD, as we calculated earlier, this is nothing but biochemical oxygen demand, and this is the most important parameter. If a higher amount of organic content is there in the wastewater, it requires high amount of BOD. How the BOD is varying with respect to time and temperature, that we'll see in these problems. Determine the 3-day BOD at 25 centigrade if a 5-day BOD of sewage sample is 21 milligram per liter. Assume KD is equal to 0.23 per day with base E at 20 centigrade. So Y5 is the notation for BOD at 5 days incubation time is equal to 200 milligram per liter, and KD20 rate constant, the deoxygenation constant at 20 centigrade is 0.23 per day, and D is nothing but the incubation period is given as a 5 days here. So that is nothing but incubation time T is equal to 5 days. So we are using this equation. Wi-Fi is equal to L naught into 1 minus e to the power of minus kd into T. So before that, we should know the L naught value because Wi-Fi is known to us and kd is given to us at 20 centigrade and 5 days time T also known to us. The L naught is not known to us. So L naught we should calculate. L naught is equal to Wi-Fi divided by 1 minus e to the power of minus kdt. You substitute and get a 293 milligram per liter. What is required here? Y3, BOD at 3 days and 25 centigrade. 25 centigrade is a different temperature than 20 centigrade for the deoxygenation constant value. For a given, for any other temperature other than 20 centigrade, we have the formula KD at given required temperature is equal to KD at 20 into 1.047 T minus 20. KD at 25 we want. So at 20 centigrade, it is KD value is 0.23, 1.047 into 25 minus 20 in the power of, this is exponent. So you are calculating this KD at 25 as 0.289 per day. So you have to calculate Y3, that is nothing but BOD at 3 days. So Y3 is equal to L naught into e to the power of minus KD into T. L naught already we have calculated as 293 milligram per liter. That we will bring here, and KD at desired temperature 289, and incubation period, this is for 3-day period. That means T is equal to 3 days. So Y3 is equal to 293 into 1 minus e to the power of minus KDT. KD is 289, 0.289, and T is 3. So you calculate and get 170 milligram per liter. Only 3 steps are required. First, you have to calculate L naught, then rate constant for desired temperature, and then BOD for known period of incubation and temperatures. Determine the 5-day BOD at 20 centigrade if 1-day BOD at 25 centigrade is given as 100 milligram per liter. So this problem is different. If 1-day BOD is given at 25 centigrade. So now we will assume that KD is equal to 0.23 per day, the standard value we have to assume. So Y1 is equal to 100 milligram per liter, T1 is equal to 25 centigrade, and T is equal to 1 days. KD is equal to this thing. What is the formula we have? Yt is equal to L naught into 1 minus e to the power of minus kdt, or L naught is equal to Yt divided by 1 minus e to the power of minus kdt. So here 1-day BOD is given. So that's why we are taking T is equal to 1 day here. So, and the 1-day BOD at 25 centigrade is given here. At 20 centigrade, constant is 0.23. At 25 centigrade, what is the constant value, KD? We have to calculate. So KD at 25 is equal to KD at 20, 1.047 T minus 20. KD at 25 is equal to 0.23, 1.047 25 minus 0.289. So therefore, your L naught is equal to, because this value is given for 1 day BOD at 25 centigrade. At 25 centigrade means that rate constant is different, and time of period is incubation period is only 1 day. So that we are applying here. And we are calculating at 289, 0.289, and 1 day means T is equal to 1, 400 milligram per liter. So what is required? 5-day BOD. Wi-Fi is equal to L naught into 1 minus e to the power of minus kd into T. So you substitute this 400 here, and what else is there? And 25 at 20 centigrade he was asking. So 20 centigrade means kd is equal to 0.23. And what period of incubation? 5. T is equal to 5. So T is equal to 5, kd is equal to 3, and LD, L naught value is equal to 400. So you substitute all the values here, 273.6 milligram per liter. Determine the ratio of Wi-Fi and ultimate BOD at 20 centigrade and 5 days. Assume KD is equal to 0.23 per day, base E at 20 centigrade. KD at 20 is given 0.23 per day. T is equal to 5 days. Ultimate BOD is equal to L naught. And Wi-Fi is equal to L naught into 1 minus e to the power of minus kdt. Or Wi-Fi by L naught is equal to 1 minus e to the power of minus kdt. What is asked here? Ratio of Wi-Fi and ultimate BOD. Ultimate BOD is nothing but your L naught. L naught. That is at T is equal to infinite. So when you substitute all these values, you are getting a 0.684. So Wi-Fi is equal to 0.684 L naught. That is 5-day BOD is 68.4 times of ultimate BOD. Our ultimate BOD is equal to 1.46 times of 5-day BOD. So this is an important relation which will be coming in the treatment operations of wastewater. A 2% solution is incubated at 20 centigrade for 5 days, during which DO depletion is found to be 4 milligram per liter. DO depletion is 4 milligram per liter, dilution factor is 2%, so 100 by 250. BOD is equal to DO depletion into dilution factor, 4 into 50, 200 milligram per liter. The BOD5 of a waste at 20 centigrade is to 600 milligram per liter. Determine how much BODU remain unoxidized after 20 days. Assume KD is equal to 0.23 per day base 20 centigrade. So KD is equal to given 20, that is 0.23 per day, and 5 days. BOD 5 is talking here. So T is equal to 5 days. And Wi-Fi, because BOD 5 value is given as 600. So it means Wi-Fi is equal to 600. Ultimate BOD is equal to L naught, which is also equal to BODU. So Wi-Fi is equal to L naught into 1 minus e to the power minus kdt. L naught is equal to Wi-Fi by so on and so forth. So L naught is equal to Wi-Fi means 600, and at 20 centigrade only the data is given. So 0.23 into 5. So we calculate here 878 milligrams per liter. This is ultimate BOD. BOD after 20 days means incubation period is 20 days. So T is equal to 20 days. Temperature is not changed. So T is equal to 20 centigrade. And temperature is not changing. Rate constant also not changes, 0.23. So Y20 is equal to 878 into so on and so forth, 8.82 milligrams per liter. BOD, this ultimate unoxidized is equal to only 1%. That means how much is this value? 8.82 divided by 8.878. So this is what is the calculations we should be more careful about. After 20 days, only 1% is unoxidized, and oxidized is 99%. Most of the BOD is completely oxidized after 20 days of incubation period. So this is more important in the calculation part. And another thing is the important parameters, whatever are there, we will talk here. The suspended solids, BOD5, COD, oil, total solids, TDS, level solids. These are the major parameters which are important in the wastewater. All the values are expressed in milligram per liter except settleable solids which are given in milliliters per liter. That is, we are testing the settleable solids using a Wim Hof cone. The sewage now classified as strong, medium, and weak. So you can see here the BOD value will be around 400 to 450 milligram per liter for strong sewage. For medium, it is 200. For weak, it is 100. Similarly, suspended solids 350 milligram per liter, 200 milligram per liter, and 100 milligram per liter. So oil again like that. The most important thing is we are having one more parameter called COD, which is discussed in another video. So this is a chemical oxygen demand. BOD is the biochemical oxygen demand. COD is the chemical oxygen demand. Here in BOD, the organic matter is utilized biologically. In chemical oxygen demand, the organic matter is utilized chemically. So here in BOD, most of the rapidly biological active material are decomposed. In chemical oxygen demand, both active and inactive are slow reactive, so they are also decomposed. So COD value is always greater than that of BOD in account of that extra value configuration of that slow biodegradable material. More amount of COD BOD ratio means more amount of slow biodegradable material is there. So now you do that calculation here. So for COD by BOD, a strong sewage, 1000 by 400, it is 2.5. If I take BOD by COD, it is 0.4. COD by BOD for medium sewage, it is 2.5. For BOD COD, it is 0.4. For weak sewage, it is 2.5 once again. And for BOD COD, it is 0.4. What does it indicate is 0.4 is the ratio which is more critical here. What exactly is that means? The sewage is having a biodegradable BOD COD ratio of 0.4 to 0.8, more than 0.4. It is easily biodegradable. Less than 0.4, it is poorly biodegradable because of higher content of slowly biodegradable and non-biodegradable material in the sample. So this is what is to be understood before we go for the treatment operations of any sewage or wastewater. So these are the major characteristics.